Okay, guys, today we're going to finish up essential question 3, which is how do I trace the atomic model through history? So we're going to talk about 6 scientists that I'll expect you to know and know their contribution to atomic theory. Okay, so you're working on your timelines. I'm just going to go over this information with you. So atomic theory goes all the way back to 460 BC. Now that's when Democritus was born, but Democritus lived 2,500 years ago. I want you to think about how long ago that is, okay? And how he was even able to come up with the idea of the atom, okay? That matter was made of something so very small that we couldn't see and couldn't, physically really touch or talk about. He was the first person to say, okay, I know that matter is made of atoms, okay? 2,500 years ago. He was a Greek scientist. Well, unfortunately for him, Aristotle was a Greek philosopher who everybody knew, okay? Now, Aristotle was only 14 years old when Democritus died. Aristotle was a student under Plato. So we're talking about some major Greek philosophers. We're talking about people who had lots and lots of influence on the people that lived during that time period. Well, Aristotle said, there's no way. I know that matter is made of earth, fire, water, and air. Okay? That's what Aristotle said. Earth, fire, water, and air. Everything is made of those 4 things. And so as soon as he discredited Democritus, as soon as he said, this guy's wrong, everybody believed him. Because they had no reason not to. He was very intelligent. He was a leader in philosophy. He had studied under some major people who are really well known. So as soon as he discredited Democritus, it halted all work on the atomic theory for 2,000 years. Okay, 2,000 years, people were just like, well, Aristotle said it wasn't true, so there's just no way it is. Okay? So along comes John Dalton. He lived from 1766 to 1844. He was the first person after Democritus to say, okay, here's my atomic theory. Yes, all matter is made of atoms. Okay? His other 2 main points were that all atoms of a given element are identical in mass and properties. We know that that's not necessarily true anymore because of isotopes, right? So we know the mass can go up and down based on neutrons, but their properties do always stay the same. The third piece of his atomic theory was that all atoms cannot be created, destroyed, or subdivided. Now, we can synthetically create elements in a lab, and we also know now that atoms can be subdivided, right? Because that was like the atomic bomb in World War II, nuclear fission, right? Split the atoms apart. That's what caused the explosion. So there are some pieces of John Dalton's theory that we now know are not true. But at the time, the fact that he was even going back to, okay, all matter is made up of atoms again, that was a major thing, okay? So the next few scientists were all students of each other, okay? So J.J. Thomson comes along and says, yes, I agree with you, John Dalton, all matter is made up of atoms. So let's talk about what the atom looks like. Okay, and J.J. Thomson came up with what we call the plum pudding model. Does anyone know what plum pudding is? Plum pudding, anybody? Yeah, it doesn't look real great either. I'll show you a picture. It's like a Christmas dessert. And it's like bread pudding with raisins in it. Okay, so this is plum pudding.
I don't like it.
Yeah, it doesn't look good as it does it. So, but his idea, it was a good model, okay, because his idea was that where you see the raisins, those were the positive parts of the atom, which we now know as protons, right? And everything else, so the breading part, would have been the negatively charged part, so your electrons. Now, at the time, we didn't have names for those things, but this is what his model was. So, I would compare it to like chocolate chip ice cream. Have you guys had chocolate chip ice cream? So like the chocolate chips would be your positives, and everything else, the ice cream part, would be the negatives. Okay? So that was his model. That was 1904 was his model. Now after that came Ernest Rutherford. Now Rutherford was a student of J.J. Thomson, and he set out to prove the plum pudding model. That's what he wanted to do. So he did the gold foil experiment where they put a piece of gold foil and they sent a ray of positive charge through it, expecting it to go right through, but instead the charges came back and they were focused all in the middle. So this is when they discovered the nucleus. Okay, they discovered that most of the mass of the atom was in the middle, and that's when we got the names for protons and neutrons. So Rutherford discovered the nucleus. Okay? Niels Bohr then was a student of Rutherford. So see how they were all students of each other? They're all kind of building on each other's research. Rutherford came up with what we call the planetary model. Now, think about our solar system. The planets all orbit around the sun, right? So the idea of the planetary model of the atom was that the electrons orbit the nucleus just like the planets orbit the sun. So where before in like the plum pudding model, the electrons were just kind of hanging out wherever they wanted to, Niels Bohr came up with the idea that they actually were on orbitals, and the electrons could jump from one orbital to another depending on how much energy they had, but they were orbiting the nucleus just like the planets orbit the sun. Okay? So those are the 6 scientists that you're responsible for knowing. So you'll want to hold on to your timelines because that gives you all of the information. You're going to keep those. Okay? You're going to keep those timelines. But you will be responsible for knowing each of those scientists' contributions to atomic theory. Okay? So essential question 3, how do I trace the atomic model through history? We're doing it with those timelines.